the difference between AI, which is working with flat data, and AI that has been enhanced with graph-based data, which is contextual, is that flat data will tell you sort of what happened, right? While a graph-based data on which AI, if AI is trained, the graph-based context helps AI to understand why it happened, how it connects to the associated events, and what might happen next.
Welcome to GraphGeeks in Discussion. I'm Amy Hodler. Today, I'm sitting down with Sumit Pal, who brings incredible depth from his time as a Gartner VP research analyst focusing on data and graph technology. He's now the strategic technology director at Graphwise. We'll be diving in today on how graphs enhance AI, both from getting your data AI ready, but also by giving AI the context it needs to deliver better results. Sumit, it's great to have you. Thank you for joining us.
Thank you, Amy. Thank you for inviting, and I'm very excited to have this discussion with you and help bring in graph and evangelize graph-based concepts to a wider audience. Thank you.
Great. Well, we're excited to have you. I do want to just start with to help our audience kind of understand your background. Can you tell us a little bit about your Gartner days and how that brought you in touch with graph technology?
Yeah, actually, that's a good question. And I have been doing graphs for a long time. I've been doing graphs since last millennium, in fact. During my bachelor's in computer science, there was a course on graph theory. It was more theoretical course. And I was very fascinated with the kind of algorithms graphs could solve and the way you could represent a lot of problems in a graph-based approach. And that made things much more intuitive from a solving perspective. From a more commercial perspective, I've been doing graphs again from 2006, 2007, when one of the well-known graph databases was actually not a database, but a library, which you could, put it into the middle tier. And I used it to solve certain problems, which a lot of companies do solve now, is to figure out influential mapping, how certain providers can influence their drugs across their network. That was a problem we were trying to solve, and I used graphs extensively to, again, as I had to write a lot of the algorithms myself that time. And I've been using knowledge graphs since about 2014, after Google, started using the word knowledge graphs from 2012 when they changed some of their algorithms for doing the search. So that's been mostly my background. At Gartner, I was in 2018. That year was called the Year of Graphs, and in 2019, Gartner being in the thought leadership, area, I approached my management to, we should write about graphs, and everyone told me, no, graphs are not essential. They are not what we do. You shouldn't write about them. But I went on and wrote about it, and that was the first paper on graphs at Gartner. And after that, I wrote 3 more papers, one on graph use cases and one on using knowledge graphs. And that's what, is a little bit of a background.
Yeah, so quite extensive, and you've got a lot of experience. And I always enjoy speaking with you because you've got such a breadth of touch points, as well as talking, to different vendors and customers, academics, analysts, about different aspects of graphs. And I've got to say, when you said the year of the graph, I was like, oh, are you the one that started that? So it's a kind of a little of an inside joke for graph people that no, this year is the year of the graph. So I can blame that on you, I guess, maybe. So let's on a little more serious note, I did want to talk about this idea of graphs helping people get their data AI ready. And it's something you and I've talked about, and I would like to hear a little more from you on how graphs help organizations either identify or resolve data quality issues, specifically that they couldn't do with AI today. So how does that help them get AI ready?
Sure. And, we are all talking about AI readiness, and AI readiness means a lot of things, readiness from a technology perspective, from a people skill perspective, from a process perspective, and of course, getting the data AI ready, right? Now, talking about one of the more important areas about data being ready for AI, the first comes to my mind is data quality, right? And data quality today is not just correctness of the data. It also means a lot about the semantics being correct about the data, what you're trying to represent that data, right? like, we moved away from a keyword-based search to semantic search or concept search. The idea of concepts is so intertwined with the idea of semantics, and that semantics is often hidden in the data. For example, if I am entering names of persons, right, and if I encounter a name called Paris, we as humans, the first thing we would think is, oh, Paris, the city. We would not think about Paris Hilton, right?
Yeah.
Now, however, if I encounter the name Hilton, I would think about the hotel chain, not again about Paris Hilton, right? So it's all
Uh-huh.
about context, right? And I
Uh-huh.
think a few months back, I read this paper or I got an abstract of this paper, which says that high quality data can even enable smaller AI models to match the quality of larger models, especially when they're doing code generation, right? So now coming to this idea about knowledge graphs can help organizations identify and resolve a lot of data quality issues for AI. For example, in contextualizing the data, because knowledge graphs can model relationships across entities, people, organizations, rather than just storing data in isolation. And this contextual understanding can help AI in multiple ways, right? To detect anomalies. For example, if you enter a person's age as 100 or 200, it's clearly wrong, right? You get that semantics that a person's age cannot be more than 100, 110, 115, right? And that inherent meaning can be very well sort of conceptualized within a knowledge graph. Knowledge graphs can help to catch contradictions and inconsistencies, right? And AI models that are trained on inconsistent, conflicting, or erroneous data can produce unreliable, results or predictions. Similarly, things like entity resolution or deduplication, just like the way I talked about Paris being either the city of Paris or Paris Hilton, and then
Uh-huh.
Hilton, whether it's a hotel chain or Paris Hilton, right? With entity resolution and entity disambiguation through relationship matching, through attribute similarity, linking to external data like Wikidata or DBpedia, can reduce a lot of these inconsistencies or skewness of the data, avoiding duplications, right?
So, in regards to thinking about graphs being used for disambiguation or deduplication, there's also, I would assume, a role for graphs to coordinate the multiple different data sources that you need for AI because AI is so data hungry.
Oh, absolutely, yes. And that is the whole value add of graphs, right? It has been one of our lines, right? You connect your data with graphs, right? Because the same data could be existing across different data silos. The whole approach, the whole problem of data silos, metadata silos is widespread and rampant across most organizations, right? And this is where graphs can help to bring in and connect these disconnected data sets through a schema and ontology that can enforce rules, that can validate the data type, the help in the constraints, and thus help in eliminating anomalies or, often helping in building the missing links that can improve the data quality, right? And RDF graphs, specifically RDF graph models, the graph data models, which are based on semantics and W3 standards, are very well suited for this because, as you may have heard about this term called shackle, right? It's the shape constraint language that is part of the standard RDF validation, a declarative way to clean and validate data, right? Where you can declaratively say that a particular data set must belong to this concept or this should have these kind of semantics through constraints we call as shackle shape, right? You just don't have any cardinality based or range based validation, but you can also have conceptual validation that this particular entity should be a subset of another entity, right? For
Yeah.
example, if you're entering data about humans and by mistake you enter data about a horse or a cow, right? It's totally wrong, right? Because the concepts don't match. So that kind of a thing is what graphs, especially graph models with RDFs, can help. I hope that answers your question.
It does, and it actually made me think. I always think about the different data sources we're trying to bring into to AI because it is so data hungry. In particular, I've heard that a lot of large language models have difficulty with conflicting data sources. So you might be using RAG to, augment your generation, and perhaps you're trying to augment with multiple different data sources, which makes sense. But when those data sources also don't agree with the semantics for something, I think having a system in place that can enforce those constraints, enforce definitions, enforce meaning, is just really essential, so that so the LLM is just not making it up or making the decision, that you can kind of enforce that declaratively.
True, true. And I think there has been a lot of controversy around how AI, if the training data has a lot of duplicates, how AI systems behave. And Anthropic did some
Mm,
research, I think, where they came up with where they came up with the research is that it says it does not affect duplicates data, does not affect till a certain level of duplicity, but after
mhm,
that it's definitely starts affecting their models, right? Now,
mhm,
leaving aside just the AI part, right? We all know as data engineers, I've been a data engineer in the past, the amount of work it takes for data engineers and data scientists to deduplicate data, right? A lot of ETL code, a lot of
mhm,
scripts, right? And deduplication inherently is a process that sort of involves identifying and linking records across different silos, right?
mhm,
An RDF based graph, the very good part about it, which I really always liked, is it will never allow duplicate entities to get into your system, right? With if you're define your tackle rules specifically.
mhm,
So I think graphs are very powerful in detecting and eliminating duplicates and conflicting data across silos through entity resolution. They do the deduplication through, similarity algorithms, or even sometimes relationship-based disambiguation.
mhm,
And the benefit to AI is it, eliminates duplicate training examples. It can prevent
mhm,
inaccurate or contradictory sort of features, right?
mhm.
And have more consistency in the answers, eventually reducing hallucinations, to a certain extent.
So that's all, which I completely agree, and I think we've got data that proves that the quality is better, accuracy is better. But I also think that there are things that you just don't see in non-graph systems, as people who've worked in graph for a while. So if you think about AI systems working with flat data versus AI being enhanced with graph-based context, can you talk a little bit about how that might look differently to the AI, or what the responses might be if you're looking, if you've got that structure, with graph versus just a flat file or flat relationships?
Yeah. I think that's a very good question, and it's very critical also to understand, the evolution of AI maturity with this, right? The difference in my opinion, the difference between AI, which is working with flat data, and AI that has been enhanced with graph-based data, which is contextual, is that flat data will tell you sort of what happened, right? While a
Mhm,
graph based data on which AI, if AI is trained, the graph based context helps AI to understand why it happened, how it
mhm,
connects to the associated events, and what might happen next, right? That is how I think a flat data from a graph based context data will, give AI much more edge in terms of, flat data is typically organized as tables or arrays or whatever you call it, and then each record is independent, right? While a graph
mhm,
enhanced data is organized as nodes with edges and relationship, and every record is connected through meaningful relationships. And it is sort of inherently multidimensional and semantic, right? Now, one example I would give is a lot of financial organizations use, fraud detection techniques. Now, fraud detection techniques, they use mostly plain machine learning algorithms, which are they do a lot of feature engineering, they extract out the features. It has been found that it can it can reach a certain level of accuracy with the fraud detection. But then when you overlay graph-based models on top of that, because basically fraudsters are working as cohorts, right? They are clustering, they're generating a lot of fake accounts, and how these fake accounts are connected. Once you overlay that graph model, suddenly the accuracy of these machine learning models improves dramatically, right? And going to a more advanced approach, like using graph neural networks, right, where you also put in a lot of context. Graph neural networks are being used in a lot of recommendation based algorithms, like Pinterest uses graph based and graph neural networks, again, to get better recommendations and better sort of connections between different users and things like that. So what I would say is, flat data can learn local patterns through statistical correlations and doesn't inherently understand the relationships, which limits explainability and generalization. While a graph based approach can incorporate these graph embeddings, reasoning, right? You can deduce new facts, it can capture the network effects, influencers, and can understand the causality of it, right? What is causing this particular pattern to appear? That's how I would put it.
The addition of causality is just I'm so glad you mentioned that, because I know there's also a whole thread of causal graph work going on as well, and it's interesting to see these different areas come together, because I do agree correlation's really interesting, but when you can understand the why behind something, that's when business leaders, organizations can make real decisions, because it's knowing something happens at the same time is nice, but when you can understand what the likely cause or influence is, I think that's when really strategic decisions can be made. Now, you mentioned some use cases, and I wanted to poke a little bit on the potential for domain-specific relationships or business rules that graphs allow us to add to AI systems. Can you talk a little bit about that?
Sure, sure. So what you're asking is how graphs can enable AI to sort of understand the domain-specific relationships across business entities, right? Is that, or business rules, right? Is that your
Yeah, understand and possibly enforce
endpoint? Yeah.
certain rules. Yeah.
Correct. And yeah, we'll come to the business rules part where, again, shackle is a very useful way of enforcing business rules once you have
Mhm.
defined your entities in a very declarative way, right? You're just declaring,
Mhm.
you're not writing code. And it's the graph engine that is understanding the shackle rules and implementing the business rules in a declarative way to flag out data validation or flag out errors. Now, what I would say is graphs are quite powerful for enabling AI to understand domain-specific relationships because they model knowledge in the way that humans think, right? In terms of connections, entities, and logic, right? Um, Traditional data models like tables or even semi-structured data like JSON can treat relationships as secondary or implicit, but graphs, the relationships are very like as I call them, they are the first class citizens, right? The relationships are very explicit, right? And when you're using graphs for AI can now use these graph models to traverse and reason through multi-hop relationships through reasoning. And these can generate much richer context, much richer features that can help in the learning process. Next is graphs can also embed a lot of the domain specific ontologies, right? You brought up this idea about domains, right? There's a lot of
Mhm.
domain specific ontologies and taxonomies which graphs can really bring in and merge easily with your instance data. So now, once you do that, AI can now make semantically informed predictions, in my opinion, right? Like, for example, making the right kind or recommending the right kind of treatments for certain drugs, for certain diseases, or even figuring out the right kind of drugs for those certain diseases, right? Now, graphs can also support sort of a rule based reasoning along with plain machine learning, based on path-based queries or constraint validation or inference rules, as compared to ML, which is mostly like statistical learning. So now with this graph-based layering, AI can sort of handle edge cases. It can align decisions with the domain knowledge and business logic. Not sure if that makes sense or that helps.
I think it does, kind of bringing it together. Do you, for our listeners, can you maybe tie semantics and ontologies together, since you actually started talking a little bit about both, and how a lot of times you see papers on AI and a lot on GraphRag right now on the importance of semantics without discussing ontologies as well. So I'd like to kind of let's bring those two things together. If you can kind of explain the difference, but how they play a part together.
Right. And yes, you're right. Ontologies and semantic models, I think, play a foundational role, in my opinion, in making AI outputs, both from a training perspective and even from an
Mhm.
AI inferencing perspective, more explainable, especially in very complex domains like, finance, healthcare, legal, etc. So ontology, in my opinion, is sort of a formal, structured representation of knowledge about a given domain. Think of it more as a schema, right? Where the schema is talking about the entities involved in the domain, their attributes, their relationship, their rules, the constraints. Think about it more from a conceptual perspective, with concepts like subclasses is a part of things like that, right? And this creates that semantic model on which knowledge graphs are based, right? And a lot of domains have already developed their own ontologies and taxonomies. In a lot of cases, these ontologies and taxonomies are embedded in business rules. They're embedded in a lot of scripts and ETL data, right? Now, ontologies can help AI systems by structuring the features with real world meaning, the semantic aspects, right? Helping in the feature engineering, enabling reasoning over rules, right? Just the whole idea about, like, the example that we give, like all birds fly. Sparrow is a bird. We can infer that, sparrows can fly, right? These kind of newer generation of facts is very possible because of these connections, of these dependencies, and also because of these way in which you model these the semantics of it, right? Ontologies, in my opinion, can also help make AI outputs explainable by encoding the logic behind the prediction, helping the traceability aspects. What is the semantic path? Why did I get this answer? And helping making more transparent decisions. The other part about ontologies, I would say, is when you brought up that I thought about answering it, but I forgot that time, was about the silos, right? When data is split across
Yeah.
silos, right? Ontologies can help in interoperability across different sources of data, and ontologies can unify this with a shared vocabulary, with mappings between terms and different formats, and that can help in bring a lot more consistency to the data. So it's a long answer to your short question, but
Yeah, I think it's well covered. I think my shorthand, some of the shorthand thoughts I have when I think about ontologies and using them with systems that are already trying to sense and extract semantics, is that they also help make the whatever the AI system output is relevant for my business or my scenario or my research, because it maps, it grounds the response in something that I've already structured the meaning of for my support documents, or my customer database. And it forces you to it forces the answers to be relevant to whatever
domain.
the business situation. Yeah. And
Exactly.
I just think that's so important, because a lot of systems you can get, if I get 50 great answers from my LLM model, which one do I choose? Which one's the right one for me? And so having that, put into the situation more contextually relevant, I think is just really important.
Good, good,
Yeah.
exactly. And spot on. Absolutely, yes.
Yeah. So at the earlier you had mentioned the potential for graphs to make the large systems more trainable on smaller data sets and smaller models themselves. And I was wondering if you wanted to kind of expand a little bit on that, if you're working in that space right now, or what you're seeing there.
Yeah, I think small models, as we abbreviate them as SLMs, right? Small language models. Small
Yeah.
language models, in my opinion, will become more prevalent as as adoption goes on in the industry of language models as such, because of the costs associated, because of latency, and also a lot of things like SLMs can be built by fine tuning or by knowledge distillation of the original large language models, which is again very domain specific, right?
Uh-huh.
In my opinion, SLMs and domains match very well. And when you have to build an SLM, if you feed, rather than feeding the whole internet data or all endless set of books to for training purposes to a language model, 99% of which may not be relevant to a domain. For an SLM, you are exposing only the data that is relevant to the enterprise, to the vertical. And that is where knowledge
Yeah.
around the ontologies and taxonomies of that particular domain or vertical becomes very important, right? And now your SLMs, because they're not so big in terms of the weights, they are less biased. They are probably they are trained on more cleaner data, because enterprise data, it's not sort of polluted with a lot of outside noisy data, right? Which is out there and on the internet. So applying a graph-based model when you're building SLMs for your enterprise use cases, I think helps in bringing a lot more semantics, context, and that can help in understanding the causality of of the different use cases, of the different answers that your SLM is giving. So I feel SLMs are going to become much more popular as we go, and as LLMs become much more commoditized. More organizations will be looking to build SLMs to provide that differentiator. And a lot of these SLMs will, in my opinion, be powered with knowledge graphs and graph-based data, uh, which could be hierarchical, which could be more connected across the different data silos.
Do you think, so kind of a crazy, I don't know if it's a crazy thought or not, but do you think that we're going to go back to more more advancements in AI that aren't just about scale and size? It feels like the last, several years, it was just about more data, larger models. I mean, large language models. Now you're talking about small language models, which I assume would also, being smarter about how you're doing the training. This concept of, zero shot learning that we were all excited about many years ago. And it was like, well, no, that's not the way to go. You just throw more stuff at these models and they get better. Do you think we're on the verge of shifting away from the large, the scale out AI systems, and now I don't know if it's scale deep, scale in. Yeah, what are your thoughts there?
I think so. I think that is where it will, it will go. We, rather than thinking just about scale, because I think the general thinking has been scale can only take you to a certain level of accuracy, and if you want to go
Uh-huh.
beyond that, the tendency has been to add more layers to your neural nets, or add more
Uh-huh.
data, right? And we probably have exhausted all the data, right? We could never think about that word, right? Exhausting of the data, but now I think we have approached this thing,
Yeah.
right? But I think again, quality is more important than quantity, right? If you're training, even if you have more data and you use more parameters, right? We already have reached,
Uh-huh.
I think, trillion parameters or so. right? Even if you have more parameters and more knowledge, if it's the quality is not good, then again, it's all garbage in, garbage out, right? That's where
Yeah.
I think eventually we will get out of this rat race of more data, more parameters, and focus more on what is important, right? Eventually this will reach a plateau, and we'll start thinking more into going more deeper into a specific domain or a set of domains, and having models that can get, and that will probably, in my opinion, can also reduce the hallucination, improve the ethics and the bias around some of the answers that we get from LLMs.
It's interesting. As you were speaking, I was thinking, very much like a child, you go through, a rapid growth period. You have growing pains, as we're all familiar, can be both a physical and, can be an analogy for what maybe we're going through right now. Uh, can you tell me a little bit about, thinking about us maybe getting, I don't know if we're through our growth pains, but maybe we're moving towards not just a scale out approach. You're moving past that. Tell me what you're excited about right now in this space, like maybe some things you're working on, or research that you're just tantalized by.
Yeah, I think we are looking more at helping organizations leverage graph RAG based approaches. RAG has
Mm.
been the rage last couple of years. A lot of organizations are going into RAG with vector databases, and we are taking it to another level where we are using graph RAGs as a way to solve some of the challenges around limitations around RAG, where RAG can only work with mostly unstructured data, while if you bring in knowledge graphs can unite both structured and unstructured data, and your graph RAG based approach can work with both structured and unstructured data. Graph RAG also helps in getting better answers, is what we have seen once we have implemented our own approach of doing graph RAG. One of the examples was, we took all our collaterals on our website, and we built a knowledge graph on top of it.
Right.
And then we asked certain questions like, who are our customers in the US government, right? And because our knowledge graph was built with a lot of semantics, with GICS ontology, which is the general industry classification ontology, plain RAG could not figure out that one of the leading space agencies, which is a government agency, is our customer, because nowhere was it specified that it's a government agency, right?
I see.
Uh, but when we bring in graph which is semantically enriched with more ontology and taxonomy, it can quickly figure out through hopping through the relationships that the space agency is a government agency. It can give back answers that are more relevant in that way, right? So this is an exciting field, and this is where we are building a lot of use cases, building a lot of demos to show the value of graph RAG, specifically to answer some of your more complex questions, which could be residing across different data silos that may have that may have very ambiguous data, right, which is not
Yeah.
properly interconnected. Yeah.
I love that example, because with the space agency being, a government organization, because I often hear people that aren't familiar with graphs saying, well, if you just cleaned all your data first, if you just got all your data in a perfect structure, then and got your definitions or your ontology, as we would call it, your schema all figured out ahead of time, perfectly clean, you wouldn't have to. And I'm like, well, you would still miss, your
Correct.
tertiary, your third or fourth hop. However, when have you ever had completely clean data? It just doesn't come in that format. And
Correct.
you have an acquisition and your data comes in a different format. Your marketing team manages and handles data and defines the meaning of the word product differently than your supply chain does. So good luck getting things perfectly in your system, whatever that system might be. So I always chuckle. I like that example because it's like you just never have data in a universal format. You're always going to be doing
Correct.
mapping and things coming in from silos. Uh, and you were talking about what your company's doing. Just to remind people, that's Graphwise. Is there anything Graphwise is offering specifically for GraphRag, or is that more of a capability or a practice that you have services in?
Yeah, we provide specific graph rag capabilities. We have
Okay.
introduced ways to talk to your. We have developed different sort of agents to try out. We have a variety of approaches to query things from your knowledge graph, right? Which are to build more context rich conversations, to reduce hallucination or reduce the non determinism aspect, add explainability. We have done a variety of ways through which you can interact with your data with the graph model on top of it. And yeah, this is all in-house proprietary built solutions. We also have developed ways of doing better entity linking. There is now a lot of talk around how LLMs can help to jumpstart your knowledge graph, projects where they can automatically build the model, but LLMs can take it to a certain level, right? LLMs cannot do things like entity linking. We have developed our own entity linking algorithms that have much better entity linking accuracy. So these are some of the things that we are working on at almost at the cutting edge, or bleeding
Uh,
edge.
So if anybody wanted to follow up on that information, if they have questions in general, what do you recommend that they look at?
Yeah, sure. I think our website, it's called graphwise.ai, has a resource-based web page where you can, ask questions of all the different collaterals we have. Graphwise is actually a merger of two former companies,
Uh-huh.
Ontotext, which builds the RDF graph database engine.
Right.
It's the only benchmark, graph database engine. We have published the results. And SWC, Semantic Web Company, which is a knowledge management company. And you can also go to the former companies' websites, ontotext.com or swc.com, and get a lot more answers from there. We are in the process of merging all our collateral together, but we are only halfway there. And we started beginning of the year. We plan to finish it by the end of this year. Yeah.
Yeah. I love the rebrand. I think it makes a lot of sense, and I think bringing together both the product side of the house and the knowledge management side of what people need makes a lot of sense as well. I think for time we should probably leave it there, Sumit. But it's always lovely to talk to you, and I'm curious about some of these graph reg specific capabilities. So maybe we follow up specifically on those. I'm sure people would love to hear about them. But
Sure.
thank
Yeah,
you.
we can definitely have another one on specifically on GraphRag and get a little deeper and answer more
Uh,
questions, where it works, where it doesn't work, where you should use it.
Absolutely.
And again, we are not saying, you use GraphRag everywhere. No, I always say, if things are simple, keep going with RAG. Don't change your approach, right?
Awesome. Wonderful. Well, thank you very much. Really appreciate your time today.
Thank you. Thank you, Amy. Thank you very much. Yeah.